Hello, I'm Brandon Richards with Neo4j. I'm the general manager for Asia, and I'm happy to speak with you a little bit today about introducing you to Neo4j and Graph Data Platforms and how you can make more sense of your connected data. I usually like to start with this, which shows that the adoption among of graph databases as a way of storing data has really just exploded in popularity in the last 10 years or so. There's lots of different ways of storing data, but graphs in particular have grown in their popularity faster than any other type of database. It turns out that there's some significant advantages at storing your data as a graph as opposed to storing them in rows and columns and tables. And for the right use case, it can have a huge impact. It allows you to do things that you just could never do with a traditional database. In a graph database, we're capturing the relationships between things. In this case, we call them nodes and relationships. So we understand how nodes are connected to other nodes. And that node can be a person, it can be a transaction, it can be anything you want it to be. And if you zoom out a little bit, you can get to the context. So you can have a node at the center, and we can see the little world that node is in, with things that are connected to it 1 or 2 or 3 degrees of separation away. We can also zoom out more and start to identify patterns. And we can run algorithms, graph algorithms on the entire data set. So we can get a lot of new insights. But the promise of graph databases is that you can get all of this insight in real-time speeds. Now, most organizations are on a journey with their data, and they're progressing in their maturity. Most organizations that we talk to are in this information stage. They're storing lots of data. They're using their Hadoop and large data lakes. But they're struggling to get value out of the data. And effectively, graphs and graph databases effectively allow you to connect the dots and progress more towards the knowledge, insight, and wisdom that people are looking for. Now, there's no one industry where graphs are being used exclusively. Anywhere where you have highly connected data, which is pretty much everywhere, you're going to find the need for graph databases and graph data platforms. The secret sauce of the graph database is that we can overcome what's called the index lookup problem, or the table join problem. And what this is that when you connect data in a traditional database from one table to another table, you create this table join. It's like an index showing how those two tables are related. If you have a lot of these table joins, it can become very slow when you try and do your queries. Let me illustrate it this way. I'll use a social media example. So suppose I wanted to know, how am I connected to Bill Gates? I don't know how many hops will be between us. It could be 3 hops, it could be 10 hops. So in a relational database, I might start with my list of friends and see, is Bill Gates on Brandon Richards' list of friends? And if he's not on that list of friends, then I can go to friend number 1 and see if he's on friend number 1's list of friends, and then friend number 2 and friend number 3. And you can quickly see this will get out of hand very quickly. It's an exponential function. So ultimately, most real-time applications in a database can handle up to 2 to 3 hops and still do a real-time query. If it's more than that, if it's 4 or 5 or 6 hops, they probably have to do a batch process. But even batch processes, we have to be careful about how many hops there are, because we can't let a query run for days or weeks or months. So there has to be a balance between how many hops and how relevant we want that data to be. Now, with a graph database, on the other hand, we store the relationship information with the node. So we will use an index to find a starting point, but from there on, we're just chasing pointers. So it doesn't matter if it's 5 hops or 5,000 hops or 5 million hops, we can still do that in milliseconds. So with a traditional database, we've had to live with these constraints for so long that we design our applications around them. Now with graph databases, we can now start to think a little differently. We no longer have those same constraints on our applications. So the things we can do are really quite amazing because they were impossible before. So this performance improvement effectively opens the door to doing new types of things. So we can now start to ask new, sophisticated and powerful and insightful queries of our data, things that we just couldn't ask before. We can also start to do things in real time that we used to do as a batch process. So we get more real-time responses. Thirdly, we can do better data science. So once you've connected your data, there's a lot of data science type things you can start to do on that graph that you just couldn't have done before. So you can start to implement graph algorithms in your data models, and your predictive models, and your AI and machine learning. So it gets really exciting. And that's probably one of the big areas in the last year that's really taken off. And then lastly, graphs are very flexible. So if you need to change your schema, you can change your schema in minutes instead of months. So if you have new business requirements that are coming to you, or if you have new types of data that you want to ingest, or you have new questions you want to ask of your data that you didn't think about when you started the project, all of these are not a big deal in a graph database. You will just quickly modify your model, your schema, and move on. So graph databases are effectively future-proofing your applications. So as you can imagine, being able to do things that were previously impossible, everyone is rushing to see what they can do with graphs. And it's transforming many industries. These are just a few of the areas we see graphs having an impact. So in data-driven discovery and innovation, hyper-personalization with things like recommendation engines or personalized healthcare, making better decisions. We can start to do fraud prevention instead of fraud detection. We can start analyzing our networks in real time and making better decision, or for government and law enforcement, they can have better, more relevant information at their fingertips. We see massive data integration is another area where people are getting kind of that next generation 360-degree view of their customer. Or in data science and artificial intelligence and machine learning, all the new things we're able to get out of that are we get better outcomes by leveraging graph and connected data in our models. Gartner has spoken recently about this. In fact, the last 3 years in their top 10 trends for data and analytics, they've included graph as one of those top 10 trends. And a couple of the quotes that I like from their reports, one is from 2020. They said, using graph techniques at scale will form the foundation of modern data and analytics. So graph is viewed as the future of modern data and analytics. And then earlier this year, in February, they said this: by 2025, graph technologies will be used in 80% of data and analytics innovations, up from 10% in 2021, facilitating rapid decision-making across the enterprise. So Gartner is seeing a massive growth over the next 4 years in the adoption of graph as a way of innovating in data and analytics. Now, when you look at where Neo4j stands in the marketplace, Neo4j invented the space, the graph database space. So We are the leader. We started the category. Everyone else is jumping into this category and trying to play catch up. But Neo4j is number one when you come at performance and scalability, handling workloads, and so on. And that's recognized in Forrester's wave that they just came out with in Q4 of 2020. Now, there's lots of different use cases for graphs. I would say there's probably 20 or 30 very common ones, but the most common ones are these. So we see a lot of real-time recommendations, fraud detection, network and IT operations use cases around master data management, knowledge graphs, identity and access management. Now, by no means is this comprehensive, but what I would like to do is drill more into some of our favorite industries. So if we look at the top use cases in financial services, we've got some of those that are around detecting fraud or money laundering patterns, even cybersecurity, where we're detecting patterns in real time, risk management and understanding things like who is the ultimate beneficial owner of a particular entity. We see things like transaction graphs and graphs being used in compliance and data lineage. We're seeing a lot of banks that are going into creating knowledge graphs and doing a lot of data science on top of those, especially things like starting with something like a customer 360 and then going into hyper-personalization, identity graphs and recommendation engines on what's the next best action or promotions that would be relevant to them. So we're starting to see a lot in financial services. I think our financial services story really starts with the Panama Papers. A few years ago, if you're not familiar with the Panama Papers, there was the largest data leak in the history of data leaks. This was a law firm in Panama that specializes in creating offshore entities. And they had over 1 terabyte of data leaked to the press. So this consisted of both structured and unstructured data, PDFs, database files, spreadsheets, documents. The International Consortium of Investigative Journalists, the ICIJ, they knew exactly what to do with this data. It took a team of 2 people about 2 weeks to clean and ingest this data into Neo4j and then turn it over to journalists to begin finding their stories. So for those who are familiar with it, many of the rich and famous politicians, prime ministers had to resign. A lot of celebrities and criminal organizations and terrorists were all suddenly exposed for how they were hiding their money offshore. With Neo4j, all of a sudden, it was impossible to hide in this complexity. The entities owned by other entities that are owned by other entities was suddenly crystal clear. This is an example of the graph that got the Queen of England in trouble. So this is the output of a simple query, and just an example. This was the model that was used in the Panama Papers. It's actually a fairly simple model, but when you load millions or billions of records into this model, it becomes really powerful. Now, this has almost taken on a new industry in and of itself, of companies who are jumping on this opportunity to drastically simplify the complexity, such as Dun & Bradstreet, Equifax, and others. They're offering services to understand things like who is the ultimate beneficial owner. And then they sell these services to banks and governments and others. In fact, Dun & Bradstreet are seeing a tremendous opportunity in leveraging graphs further with other offerings to their customers. So we see this as more validation. Companies like Citibank are using Neo4j for kind of their next generation master data management and customer 360. They also built into this entity resolution and identity and access management. Ultimately, they had complex set of individuals and groups of individuals that they wanted to understand, the complete graph that goes around them, or organizations and groups of organizations. And so they basically pull all this data from all their different systems into one master data repository on Neo4j. And then downstream, a lot of applications will then ping this master data repository. Their graph model, and they've blurred it on purpose, so it's not super clear, but you can get a sense of this is a little bit more complex than the Panama Papers model that was used. We can see more richness in how they are structuring their graph. They have lots of objectives, pulling data from legacy systems, making that data easy for consumption from their downstream applications. Data science readiness, another important area. The ability to use this globally and handle all the personally identifiable information regulations and control who has access to what information. As a part of the process of cleaning the data, they needed to do some entity resolution and consolidating some of these nodes. And by the context of the graph, they can do that a little better. They can also run various graph algorithms to further clean up the graph and ensure that they have the cleanest graph possible. And of course, in a bank, as you can imagine, based on where a person's role is, their region, what access they need for their particular responsibilities, they want to ensure that the right assets are handed to the right individuals. So they use Neo4j for their identity and access management, which the more complex that is, the more suited it is for a graph database to handle. We also see Neo4j being used in fraud detection applications within financial services. Most of our financial services customers don't want to share that, how they're breaking fraud, but we have, B for Bank is one example of an online bank in France that was having a lot of struggles and a lot of manual processes in their fraud detection process. And ultimately switching to Neo4j had a huge impact. They were able to start to identify fraud rings very, very quickly. And the amount of false positives that they were facing was drastically reduced. And in many cases, the example they have in this quote is that they were able to identify a ring of 11 fraudsters within a half an hour on one of the recent times that we were on site with them. So let's switch gears to manufacturing. Lots of use cases in manufacturing, from supply chain management to logistics. You can get into the bill of materials and get into a granularity there of the lineage of things. Compliance use cases, product 360, customer 360. We see knowledge graphs, trying to get insight and trends from unstructured data, improving predictive maintenance, being able to have better models for that, maintenance optimization, data science and machine learning, and of course, identity and access management. So lots of different use cases we're seeing in manufacturing. I want to give the example of Caterpillar, who most of you understand or have seen, the large trucks and tractors or their symbol, their logo everywhere. They had a knowledge graph that they wanted to build, and they had two objectives. One was they wanted to be able to answer any supply chain question that someone might have. And secondly, they wanted to be able to get some insight from some unstructured data. And I'll give you an example of that. So when a technician goes and works on site on a piece of equipment, they will fill out a report. And that report gets stored in their database as unstructured data, just like we see here. And they use natural language processing to identify entities. And basically every word becomes a node, and every node rolls up to a topic or a concept. And that concept further rolls into this big knowledge graph. Ultimately, part of the natural language processing, they identify what parts of the text are the complaint, what parts were the cause of that problem, what action was taken and whether it worked. And they basically build this large knowledge graph. Then they can start to mine the knowledge graph and start to understand things like the next time a technician goes on site and they're starting to see these particular problems, what has worked in the past? What was the cause in the past? And how has this been resolved? It's also used in product management, where they can identify certain parts of equipment that maybe are failing or need to be re-engineered. And of course, predictive maintenance. If they start to see patterns on how often certain things are failing, they can do some predictive maintenance in a different interval than they had been doing before. So that's one example of how they were leveraging their unstructured data for insight. The other one was that they wanted to be able to ask any question on the supply chain and get that answer. And they wanted to ask it in natural language. So this is just one portion of their ontology, but you can get an idea. If someone wanted to know how a particular sales model that was manufactured in a certain facility was shipped to a particular district between these dates, they could just ask that question and get that answer. Because it's structured as a graph, they can ask any question in this. Now, if this was not structured as a graph, then you would be able to optimize for very specific queries, but it would be impossible to optimize for every combination of questions that somebody could ask. And this is the kind of thing you can only do because it is on a graph database. So their knowledge graph consisted of 27 million documents, being able to do natural language search, and improving the efficiency of their vehicle repairs and maintenance. Now I want to jump to retail. So lots of use cases in retail. As you can probably imagine, Customer 360 and identity graphs are top of the list, along with recommendation engines. They want to drive more revenue, or hyper-personalization. Dynamic pricing engines, being able to change based on evolving dynamics that are happening in the marketplace, or knowledge graphs and data science, chatbots, lots of different use cases. As you can imagine, a recommendation engine may sound very simple. You go to a website and you may also like this if you're looking at what you're looking at. But there's a lot that goes into that. Things like promotions and personalization, machine learning, matching people and products. And you need to be able to do all of this in lightning speeds. So this is ideal for a graph. Companies like eBay and Walmart and other very large retailers are showing what's capable with the next generation of recommendation engines. We also see companies doing this dynamic pricing, where in some cases it took them, they can now refresh pricing 18 times faster than what they were able to do before. So in very dynamic markets, this can be a huge, huge impact. So Neo4j is a database, and we have at the center of our platform is the database, but there's all kinds of bits and pieces around it, such as a visualization tool for exploring the graph, or data science tools for helping with the data science. So we have a visualization tool called Bloom, as well as a Neo4j for Graph Data Science, a library that can improve your data science and machine learning and AI outcomes. Most importantly, for this group, it's important to know that we have Neo4j Aura, which is on Google Cloud. So Neo4j Aura Enterprise is our offering, our cloud-based offering. You can also use Neo4j self-managed on GCP, which is fine. But Neo4j Aura has lots of different features. Everything you would probably expect from a cloud database as a service. So with that, I would like to just say for the Korean market, we also have our distributor in Korea, who is MOS. And so we're happy to work with you on your graph data needs. If you have an opportunity, please feel free to reach out. Thank you.